Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aida Muzira binti Muhammad Murad and my metric number is AD180145. So today I would like to explain about the introduction, problem statement, objective and scope of study for our group presentation. Okay, assembly line balance is frequently used in design. This could happen if the size of number of workstations were physically changed by balancing reasons. For the most common type of assembly line is a moving conveyor that moves through a series of workstations in a predictable time interval. It is known as the workstation cycle time, which is also the time between successive units coming off the end of the line. So, a product is worked on at each workstation by either adding parts or performing assembly operations. Each station's assignment is made up of a variety of tasks, elements, and work units. Motion type analysis is used to explain such operations. They are in fact grouped that cannot be subdivided on the assembly line without incurring an additional movement penalty. There are three objectives in our project, which is first, to reduce task idle time. Second, determine the best method for manufacturing line. And the third one is to boost the machines and the organization's overall productivity. So our scope of studies is that we are focusing on to understanding the theory, concept, and efficiency of manufacturing line balancing, as well as measuring total production amount over time.
Assalamualaikum and hi. My name is Muhammad Ifat and I will continue our group presentation with the literature review of the project. So our project is related with line balancing, where the case study is at the Utensham Sports Center regarding the security system. So for the Utensham Sports Center, it is 5 km from Parit Raja Johor and 19 km from Batu Pahat, which is accessible, and it began operation at April 15, 2011. It also provide many kind of sport such as gymnasium, volleyball, swimming, badminton, golf, and others. So to maintain the security system and the safety of all users, it is have been monitored by UTSM security system. So for our line balancing study for UTSM Sports Center, we have chosen 5 sport, which is the gymnasium, UTSM swimming complex, UTSM golf, volleyball court, and also the badminton court. So these 5 places is very accessible for UTSM community and others local native that live around Parit Raja and Batu Pahat.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Razwan Hakim bin Mat Taufiq. So I will describe about methodology. Line balancing is a technique for streamlining the procedure to save time. Our University Tun Hussein Al Malaysia, THM, have many facilities for their students. These facilities need a correct line balance in order to serve the students. According to the observation, the concept of line balance is used in the sports center. There are several workstations, each with a distinct function. The UTHM Sports Center includes a golf, gymnasium, badminton, volleyball, and a swimming pool. By determining the performance measures, the lines balance issues may be resolved. The data for student goal for each day is gathered or assumed in order to determine the cycle time. The number of student visit each day was perfectly matched to the target output rate. So the calculation is shown in the next slide. So the first calculation is cycle time, CT. CT equal to 1 over R, where R is desired output rate and the unit is unit per hour. Next is theoretical minimum numbers of workstations, TM. So TM is equal to total T over CT. Next is line efficiency. Line efficiency is equal to total T over CT times to 100%. So next is balance delay. Balance delay equal to 100 minus the line efficiency. Next is idle time. Idle time is equal to Tm times Ct. So the total of Tm times Ct minus to the total of T. That's all from me. Thank you.
My name is Muhammad Hazimuddin, and I now will talk about the result and analysis. Below is the table shown for the overall task that related to the uh, activity. The first is the A registration, B for the student golf towards their destination, C is the badminton, D is the swimming, E is the volleyball, F for the gym, G for the checking the requirement, H is the cleaning and tidying, I is inspections. So the total time taken is around 30 hours. For the table below is the workstation 1 and workstation 2. Workstation 1 consists of A, B, C, D, E, F, G tasks, and workstation 2 is H and I work tasks. The total for the workstation 1 is 10 hours with idle time 0, and workstation 2 the total time is 20 hours and the idle time is 0. So this is the flow of the task from A to B, C, D, E, F, and then to G, H, and I. So in terms of calculation, the first is the desired output R, which 50 students per day times with a day per 12 hours for running. So R is equal to 4.167 students per hours. The second is the cycle time. C is equal to 1 over R is equal to 1 over 4.167. So the C cycle time is 0.24 hours per student. And we turn it into the minutes, become 14.4 minutes per student. For the theoretical minimum number of workstation, the total time per cycle time, so the 30 minutes per 14.4 minutes is equal to 2.083 or equivalent to 3 workstation minimum. For life efficiency, the total time is divided with the largest assigned cycle time with the actual number of workstation, so around 30 minutes per 3 times 14.4 times 100%, so the efficiency is actually around 70%. And that's all from me. Thank you.
Hello, my name is Brian Tetson Anamalin, which is my metric number is CD180171. Okay, today I will present about discussion and suggestion about UTSM sports abilities, and it feature swimming pool, stadium, gymnasium, track, hockey, volleyball, and wall climbing. On the weekdays, the average number of students each day is approximately on 50 students, and the evening hours of the UTSM center are staffed by an average of 4 to 5 students every hour. And this system line cycle is 15.6 minutes per student, and the theoretical minimum number of the station is approximately 1.2, so that we can see the line efficiency is equal to 96.153. Okay, next slide is our operator required and total required for each workstation. As we can see, for workstation 1 we have a total 10, and workstation 2 20. There are 20 minutes is the duration of the cycle time. In this case, workstation 1 has a delay of 10 minutes, but workstation 2 has no idle at all. The number of operators need for each duty, as well as the overall number of the operator needs for each workstation are outlined such as like table 5.1. And this is our conclusion and the process of creating an efficiency line in order to increase production volume from an existing manufacturing line. Assembly line must be balanced in order for the line to be efficient, and line balancing on support center is, we can see this is very important since sports center have been a very important area for many students or people to out at hand and also keep healthy. As we can see, 96.153% efficiency implies 3.847% imbalance for idle time across the entire line, and maximum cycle time of 15.6 minutes per student is required for each workstation, and the minimum cycle time for each number of station is 1.92, which is equivalent to 2. And our group would like to extend our most sincere gratitude and his bless. We would like to express our sincere gratitude to our lecturer, Professor Madya Dr. Ibrahim bin Masud, for his profound insight, helpful recommendation, and ongoing assistance in the form of expertise, excitement, and direction throughout the process of conducting the case study. That's all from me. Thank you.